We already have established this long list of tools to help solve polynomial equations, find their roots, their zeros, but each of them have limitations. Factoring doesn't always work. Quadratic formula is great, except that it has to be quadratic in form. Polynomial long division, when you're trying to use it to get factors, it is just too long. The remainder theorem and its special case, the factor theorem, we could tell without doing any division whether or not a number was a root just by plugging it in. And if we did find a root, then we could use synthetic division, which is weird but wonderful. You, instead of dividing by multiplying and subtracting, you divide by multiplying and adding. Fewer mistakes that way. The only trouble is that for all three of these, what you were dividing by had to be of the form x minus a. Had to be two terms, had to have a leading coefficient of 1, and so that did not take care of all the possibilities. The rational roots theorem, fabulous with all those, the q over p and p over q, got to get them straight, the plus and minus signs. And its issue is right in its name. It gave us the possible fractional roots. No square roots. No cube roots. No pies. So it didn't cover all the real numbers. It only covered the ones that could be written as fraction. And then Descartes' rule of signs told us how many roots there were, how many real roots, including the radicals. But it didn't tell us what they were. It was just maybe to shorten our workload when we tried all of this other stuff. But like human beings, each of these had its strengths, each of us had its limitations, but if you put them all together, maybe be able to tackle a problem and find the solution. So that's what we're going to try now.